Today's lesson is lesson 14.4, approximating square roots. A rational number, we've been talking about rational numbers in 7th grade just prior to this. So right now you have this definition of what a rational number is. A rational number is written as the ratio of two integers, or it's written as a fraction, any number that can be written as a fraction, whether it's positive or negative. Okay, that's a rational number. The square root of any whole number that is not a perfect square is considered irrational. So now we're going to get into irrational numbers. The cubed root of any integer that is not a perfect cube is also considered irrational. The decimal form of an irrational number does not terminate and does not repeat. So when you have like the square root of 3, when you have the square root of 3, if you type that in, you're going to get a decimal that doesn't repeat and does not end. And that then makes it irrational. So because it does not repeat and it does not end, technically it cannot be written as a fraction. You're going to learn about and learn ways to write repeating decimals as fractions. And I'll show you that in a later lesson. This graphic organizer here shows you the rational numbers and irrational numbers. So you have this list of different symbols or types of numbers that are rational and where they fall, and then also irrational. I don't necessarily agree with some of these things. This is one of those debatable things in math. This right here, this negative 2/3, doesn't want to let me write. I think that I would consider that an integer. It's a fraction and it is rational, but it also is an integer. It's still a negative number. I believe a fraction is a number. That's a debatable topic. So in the math world. So just know that these are all examples inside the pink area here. All of these examples are considered rational. And then you have these examples over here in the blue world, and all of those are considered irrational. You'll notice that you'll have square roots and negative square roots and cubed roots, but you'll notice that you have pi. And we've talked about pi as being the most common irrational number. It is any decimal that does not repeat and does not end, does not terminate, is considered irrational. So if you look down below here, it also just gives you in this list an additional list of different examples that would be and why it would be considered rational or irrational. So if you look, you have the square root of 12. Why is that? Because it's not a perfect square. You have a negative 0.25 with a line over it. Well, that is rational because it's a repeating decimal. Repeating decimals are rational. You have the negative square root of 9. That is also rational because 9 is a perfect square, so a negative 3 is considered rational. It's an integer. You have 72/4. Again, it's rational. It's written as a fraction, and it's also considered a whole number. And then you have that pi. Pi is irrational. It is a decimal that goes on forever and ever and ever and does not end and does not repeat. Okay, so what I'd like you to do is I'd like you to look at these 3 examples at the bottom, and I would like you to pause your computer and just write in your notebook whether you believe they're rational or irrational. Okay, R or I. Are these rational or are they irrational? And then come back. Okay, if you look at number one right here, okay, that decimal is considered irrational. Now, it's irrational because it's a decimal that doesn't repeat and it doesn't end, so that makes it irrational. So that number 2 then is considered rational. It's rational because it is a square root that 196 equals 14, and the negative in front just makes it a negative 14, so that is rational. And then number 3, the cubed root of 2, if you entered that in your calculator, that again is irrational because it is not a perfect square. 2 is not a perfect square or a perfect cube, so therefore it is then going to be considered irrational. So the other piece of today's lesson is approximating a square root. So when you approximate a square root, you're going to look at your square root and you're going to try to find the perfect squares that fall between them. This is why memorizing those perfect squares is really important. So, for example, and this is what I would like you to do when you do this. If I have the square root of 71. You need to find, and this is what I'm going to expect you to do, you need to find the two perfect squares that 71 falls between. Well, the square root of 81 is on the high end, and then the square root of 64 is on the low end, okay? So what you do to figure out about where this falls is you say, okay, 64 is how many away from 71? So you have 6, 7 away, okay? 81 is how many away? It's 10 away. So which one is it closer to? It's closer to the square root of 64. So it's about the square root of 64, which is, and you use that wavy equal sign, which is about 8. Okay, you're gonna be estimating essentially to a whole number. Now, you also need to know that when you're doing something like this, when you do it on a number line like it is right here, you would know that it falls in between the two. It isn't exactly 8, it's in between 8, and it's closer to 8 than it is to 9, or closer to 64 than it is to 9. But when you're approximating in terms of values, you would say that it's the square root, like down here, that it is approximately, with the wavy equal sign, that's what that means, approximately 8, because it's closer to it. My expectation is that when you're doing problems like that, you would write it like this, just like I did before, the square root of 71, find the two perfect square roots that you would have between them. So we had 64 and we had 81. 81 is 9, 64 is 8, and I just put them up above. You could put them down below or put it next to. And then I want you to circle how far away it is. So we said that 71 is 6, 7, right, away, and that 81 is 10 away. So therefore, underneath then you write approximately 8, because it's closer to 8. Okay, that's what I want to see. Now, this, you are not allowed to do a calculator. I mean, you shouldn't need to do a calculator. My problem is, even if you're doing it, it really doesn't make a difference, because you could, you still are going to have to find those perfect squares above and below, okay? Because you're going to have to know that. All right. So now, if you look, so that's that first example. If you look at the second example, they have you making a table of numbers between 8 and 9 whose squares are close to 71, and they take it a step further. You can pick if you're going to go to the 10th. I don't have an expectation of you doing that. In all honesty, you can use a calculator if you need to do that. Right now, our goal is to find the closest perfect square. So if you don't have a calculator available to you, you can estimate about where this is. And you are going to have to do that in geometry. That is a skill that you're going to have to use when you have geometry. And I know because my son had done it. So you're going to have to be able to approximate square roots to the nearest whole number. Okay, so looking at these problems down below, I'm going to ask you to do, let's see, I think I want you to pause your computer, and I want you to do 5, and I want you to do 7. So pause your computer and do 5 and 7, showing that work like I showed you. Okay? Okay, so for number 5. Number 5 is the square root of a negative 13. I'm not going to worry so much about the negative part. I'm going to look at it as, okay, I have the square root of 13. What are my perfect squares on each side? Well, I have the square root of 16 on the top end, and on the bottom end I have the square root of 9. Okay? 9 equals 3, 16 equals 4. Now you have to figure out how far away they are, okay? So 9 to 13 is 4. I'm doing my math in my head, I hope I'm right. 16 to 13 is 3. So which one is it closest to? It's closer to that one, so it's approximately 4. And because it's negative, it would be negative, okay? Now if you look at number 7, and this is what your work should look like. That's my expectation. If you look at number 7, you have the square root of 110. 110 falls between the square root of 100 and the square root of, that's the low end. Sorry, I put that on the wrong side. The square root of 100 and then the square root of 121. Okay? 100 equals 10. 121 equals 11. So 110 falls between, or 100 to 110 is 10 away, and 121 to 110 is 11 away. So which one's closer? It's approximately 10. Ooh, and I flipped the pages, sorry. It's approximately 10. Boy, I'm having problems with this today, my little mouse. Okay, so that's what my expectations are. If your work does not look like that, you need to make sure it looks like that, because that's my expectations on your assignment. All right. Okay, so now if you look, you're going to also have to compare or find out which one's bigger. So again, you estimate to do that. So the square root of 5 is between the square root of 4 and the square root of 3, 9. So this is only 1 away. This one is 4 away, so it's obviously closer to that, so it's approximately 2. Okay? And then you have the square root of, or just the fraction 2 and 2/3. Well, 2 and 2/3, you know, as a decimal is going to be 2.6 with a repeating 6, 2.666, because 2/3 is 0.66666. So which one is it closest to? It's going to be closest to 2. So you're really using your knowledge of fractions and what I taught you in Chapter 2 and Chapter 1 to apply now to Chapter 14. So that's why it was important that we did those chapters first. Okay. And then you also have some real-life applications that you can do. You're going to do so. You are going to look at a problem, and like it says here, a radius of a circle with an area A is approximately the square root of A over 3. The area of a circular mouse pad is 51 square inches. Estimate the radius to the nearest whole integer. Well, you know then if it is the square root of A over 3, and if A is 51, then it's the square root of 51 over 3. Well, you then divide 3 into 51 and you get 17, so it's the square root of 17, so now you estimate 17 doing what we were just doing. The square root of 17 falls between 16 and falls between 25. It's obviously closer to 16 because that's only 1 away, so then you're approximately 4. Okay, that's what I would expect you to do for a problem like that. Okay. Here's another real-life application. It says the distance in nautical miles, that you can see with a periscope. This is a periscope. I don't know if you're familiar with that. Is 1.17 times the square root of h, where h is the height of the periscope above the water. Now, on this problem, your book is asking you. It's telling you to estimate by using a calculator. I don't want you to do that. I don't want you to use you shouldn't need to really use a calculator at all. I want to see you estimating your square roots, okay? It's easy to use a calculator. You know how to use a calculator, but you understand as well how to estimate. And I'm not a huge fan of estimating, but it's something that you need to. So in this example, the issue that I had is that they calculated the square root of 3. They calculated the square root of 3 in a calculator. I do not want you to do that. So I would say, okay, you have 1.17 times the square root of 3. Well, square root of 3 falls between the square root of 1 and the square root of 4. Well, it's only 1 away from here, and it's 2 away from here. So it's approximately 2, because the square root of 4 is 2. So then what I would want you to do is I would want you to, there we go, I would want you to put here, instead of where they put this decimal, for the square root of 3, which is over here, I would rather you do 1.17 times what was our answer, 2. Okay? Because that's what we're doing. We're estimating to the nearest whole number, and that's the standard. So that's what I would like you to do. You can always use a calculator and calculate it. I don't want you to do that. So 6 feet for today's lesson. 6 feet above the water then would be the square root of 6. Well, that falls between the square root of 4 and the square root of 9. The square root of 4 is 2. The square root of 9 is 3. Here, 4 to 6 is 2. 6 to 9 is 3. 3, 6, 7, 8, 9? 3. So it's a little bit more. It's actually almost exactly in between. So if you wanted to here, because this is going to come out, if you use 2, it's probably going to come out to be about the same height. If you wanted to, you could do 2.5. So say that it's approximately 2.5, and then 2.5 times 17, 1.17. Okay. Approximating and estimating is really difficult, and it's not something that I spend a lot of time on because I like math because it's a specific value. So anyway, okay, so that is our lesson. If you want to look at some of these examples, we could do number 8 maybe real quick. Why don't we do that real quick? So you have to estimate 23 and 4 1/5. Well, the square root of 23 falls between the square root of, let's see, the square root of 16 and the square root, nope, I lied, sorry. Yes, 16 and 25. I'm thinking 20. 16 and 25. So 16 to 23 is 4, 5, 6, 7 away, and 25, this is 2. This equals 5. Oops, sorry. Equals 5, so it's close to 5. So that's approximately 5. Well, 4 1/5 is 4.2. That's going to be way higher than that. So which one is greater? It's going to be the square root of 23. It's going to be bigger. Okay, so that is your lesson on approximating square roots.